Welcome to OOTO, the out-of-the-office investigation into personal health actualization. This time, we're discussing the universe, reality, and perception. I'm Gordo, and with me is Skinny.
Hey, Gordo.
We're diving into a real head-scratcher today. It's a mystery that starts at the very edge of human knowledge, with a profound conflict right at the heart of modern physics. And what's wild is that exploring this cosmic puzzle might just give us some incredible insights into our own health and well-being.
Exactly, Skinny. So here's the roadmap for our investigation today. First, we'll examine the scene of the crime, so to speak, in a universe divided. Then, we're going to follow a century-old clue into the hidden dimension. From there, the trail leads us to a symphony of strings, and we'll even expand our search into membranes and many worlds. And finally, we'll bring it all home to figure out what it all means for the observer's reality. That's us.
Okay, let's get into it. Every great investigation starts with a central problem, a crime that needs solving. And for us, that crime is a massive contradiction in how we understand, well, everything. For the last 100 years or so, physics has been built on two of the most successful theories in the history of science. But here's the kicker. These two pillars of knowledge are fundamentally completely incompatible. They just don't play nice together.
It's truly fascinating, isn't it, Gordo? Because on their own turf, they are champions, undefeated. General Relativity, Einstein's masterpiece, perfectly describes the big stuff, planets, stars, galaxies. It gives us a beautiful, elegant picture of gravity as this smooth, curving fabric of space-time. It's why your GPS works. But then you have quantum mechanics, which governs the tiny, tiny world of atoms and particles. And that world is, well, it's bizarre. It's all about probabilities and weird jumps and things being in two places at once. The problem is, when you try to use them together, like to describe the inside of a black hole where you have immense gravity crammed into a tiny space, the theories they short circuit. They give you answers that are just nonsensical infinities.
That's the perfect way to put it. As science communicator Chris the Brain says, the math just doesn't get along. And we're not talking about a minor disagreement here. It's a deep, fundamental paradox that has kept the world's smartest people up at night for generations. It's a giant, flashing sign telling us that our picture of reality is missing a major piece. And that's where our investigation really kicks off, with a very strange clue proposed almost 100 years ago.
This timeline really drives home how long we've been stuck on this, Skinny. Just a few years after Einstein completely rewrites the laws of gravity, this mathematician Theodor Kaluza sends him a letter with a truly wild idea. Kaluza suggested, what if there's another dimension of space, a fourth one? He showed that if you rework Einstein's equations for a universe with this extra dimension, something incredible happens. The equations just naturally split out into two theories we already knew. One was gravity, and the other was electromagnetism, the force behind light and electricity. It was this unbelievable hint that the forces of nature could be unified. But it left this huge, glaring question. If it's there, where is this fifth dimension?
And you have to love Einstein's reaction. He didn't just dismiss it. He was fascinated. He wrote back to Kaluza, "At first glance, I like your idea enormously." I mean, can you imagine getting that feedback from Albert Einstein? That's the ultimate seal of approval. And for us, that's the hook. That's the breadcrumb trail that leads us down the rabbit hole. What if the solution to the biggest mystery in physics is hiding just out of sight?
Right, so to follow this clue, to even begin to search for this hidden dimension, we have to ask a really basic question. What even is a dimension? We throw the term around all the time, 3D movies, 2D art, but what are we actually talking about? To find a new one, we have to know what we're looking for.
Fundamentally, a dimension is just a direction you can move in. It's an independent line of travel. So we've got three we know and love. Back and forth, that's one. Left and right, that's two. And up and down, that's three. Each one is at a right angle, perpendicular to the others. And this simple definition leads directly to the biggest problem with Kaluza's idea, the question everyone immediately asked. If there's a fourth direction to move in, a fourth spatial dimension, where is it? Why can't I just take a step into it?
You're listening to OOTO, with research by author Paul Bulow.
Okay, so let's try to wrap our heads around this. One way physicists think about this is by stacking. So a point has 0 dimensions. It's just a location. But if you take a point and move it or stack an infinite number of them, you draw a line. Boom, 1 dimension. Now stack a bunch of lines side by side and you get a square, a 2-dimensional shape. Stack those squares on top of each other and you build a cube, our familiar 3 dimensions. So logically, to get to a fourth spatial dimension, you'd have to stack cubes. Now our brains just aren't wired to picture that, but mathematically, the logic holds up. Right, Gordo. That's a cool thought experiment, but it still doesn't tell us where this thing is hiding. And that's where another physicist, Oscar Klein, came in with this absolutely brilliant idea, which is captured perfectly by the garden hose analogy. Imagine you're a mile away looking at a garden hose stretched across a lawn. To you, it just looks like a one-dimensional line. You can only perceive its length. But if you were a tiny ant crawling on that hose, your reality would be very different. You'd experience two dimensions. You could walk along the length of the hose, sure, but you could also walk around it. Klein's genius was to suggest that maybe that extra dimension Kaluza was talking about is just like the around part of the hose. It's curled up or compactified into a circle so tiny at every single point in space that it's completely invisible to us.
I love that. And this next idea shows how we could theoretically see one of these higher dimensions without actually seeing it. It's the classic flatland thought experiment. So imagine a universe of two-dimensional beings living on a totally flat sheet of paper. Now, what would happen if a three-dimensional object like a sphere passed through their flat world? Well, they wouldn't see a sphere. What they'd perceive is a point suddenly appearing from nowhere. That point would grow into a circle, get bigger and bigger, then start to shrink, becoming a smaller circle, and finally, poof, it would shrink back to a point and disappear. They would only see the two-dimensional slice of the 3D object as it moved through their reality. So maybe some of the weird quantum effects we see in our universe are actually just the shadows of things happening in other dimensions.
Okay, so that idea of one tiny hidden dimension was an amazing first clue. But as the decades went by, the investigation got a lot more complicated. That simple idea evolved into something, well, something much grander and, frankly, much weirder. It led physicists to what we now call string theory.
So what is string theory? Well, it's a complete shift in how we think about the building blocks of reality. For hundreds of years, the goal was to find the smallest possible thing, right? Like a tiny, indivisible little ball, a point particle, an electron, a quark. String theory comes along and says, nope, you've got it wrong. It proposes that if you could zoom in to a scale far smaller than anything we've ever seen, you wouldn't find a point. You'd find a tiny, one-dimensional, vibrating loop of energy, a little string.
And the beauty of this, as physicist Laura Anderson explains so well, is just how elegant it is. Think about it. All the dozens of different fundamental particles we've discovered, all the different forces, they're not fundamentally different things anymore. They're all just different notes being played by the same basic string. A string that vibrates in one pattern looks like an electron to us. A different vibration looks like a photon, the particle of light. Another one, a quark. It turns the entire universe into a cosmic symphony, all played on these unimaginably tiny strings. It's the ultimate unification.
It's an absolutely beautiful idea, Gordo. But there's always a but, isn't there? There's a huge catch. The math behind string theory is incredibly demanding. For these string vibrations to correctly produce all the particles and forces we see in our universe, and for gravity to be included, which is the whole point, the math just breaks, it falls apart. Unless the universe has more room for the strings to vibrate in. A lot more room. It turns out the equations only work, they're only mathematically consistent if the universe has 9 or 10 spatial dimensions plus time. So Kaluza's one extra dimension has now exploded into 6 or 7 extra dimensions.
And that, right there, is the trillion-dollar question. It brings us right back to the central problem that has plagued this theory for decades. It's an incredibly elegant, mathematically beautiful framework, but it makes this extraordinary claim that we live in a 10 or 11-dimensional universe, and after 50 years of brilliant people working on it, we have zero experimental evidence, not a shred. It predicts all these extra dimensions, but we have no way to test for them, to see them, or to observe their effects. So the big debate in physics is this a theory of reality, or is it just a beautiful piece of math?
Exactly, and that lack of evidence has pushed some physicists to explore other avenues. The investigation is really branched out. String theory isn't the only possible solution on the table anymore. There are other, equally mind-bending ideas out there which you often hear lumped together under the very popular and very hyped term, the multiverse.
Yeah, and it's so important to realize that multiverse can mean very different things. They aren't all the same idea. First, you've got bubble universes, which suggests our Big Bang was just one of many, creating separate universes in a cosmic foam, maybe with totally different laws of physics. Then there's the membrane, or brain idea, which comes out of string theory. It pictures our entire 3D universe as a giant sheet, or a brain, floating in a higher dimensional space, and there could be other brain universes floating parallel to ours, maybe just a millimeter away, in a direction we can't perceive.
And finally, you have the many worlds idea from quantum mechanics, which says every time a quantum particle makes a choice, the universe splits, creating parallel worlds where every single possible outcome happens. All of these are fascinating, but it's key to remember they are all deeply speculative. You're listening to OOTOL, with research by author Paul Beulah.
So, after this whole journey, chasing clues through hidden dimensions, cosmic strings, and parallel worlds, we're at the very edge of what physics can tell us. The great mystery hasn't been solved. But the investigation itself, this whole process of questioning the nature of reality, forces us to turn the camera around. If reality on its most fundamental level is so radically different from how we see it, what does that say about our own perception? This is the detective's epiphany. The mystery of the universe becomes a mystery about ourselves.
And that really is the heart of it, Gordo. It's a fantastic question. After talking about all this mind-bending physics, how can exploring the universe, reality, and perception possibly affect our day-to-day mental and physical health? Where's the connection?
Well, I think the connection is in that word we keep coming back to, unification. Physicists are desperately searching for one single, harmonious theory for the universe. And that's a powerful metaphor for our own lives. We can't treat our health like it's a bunch of separate pieces. Understanding the universe, reality, and perception, and making healthy daily choices for diet, behaviors, and medical care is critical to our physical and mental health and recovery from hypertension. It's all one interconnected system. We need a unified theory for ourselves, a holistic approach to our personal universe, our own mind and body.
Okay, so if we're going to apply that unified perspective to ourselves, what are the key elements? What are the fundamental forces we need to be paying attention to in our own lives?
I think this is where the investigation really pays off, because the universe, reality, and perception suggests our body's health is connected to our diet, actions, nutrition, sunlight, fresh air, personal energy, and our clarity routine of alignment of our actions, words, and thoughts. Just like string theory says an electron and a quark are just different vibrations of the same string, our physical health and our mental clarity aren't separate things. They're different expressions of one unified system, our total well-being. The goal is coherence and alignment between all of these parts.
That brings us to the final, most important question. Can this shift in how we see things, this bigger perspective, really make a difference? Ultimately, can this understanding improve our mental health and relationships while supporting physical optimum performance?
I absolutely believe it can, Skinny. The answer is all about perception. When you wrestle with ideas like hidden dimensions and vibrating strings, it forces you to accept that reality is so much more complex and mysterious than what we see on the surface. That can give you a real sense of awe and humility. And when you apply that mindset to yourself, you start to see the deep connections between your thoughts, your food, your actions, and your health. The universe, reality, and perception aligns our bodies to a healthy environment for both mental and physical success. Recognizing that deep interconnectedness is the foundation. It's not just about physics, it's about seeing ourselves as part of this incredible connected cosmos. And I believe that the universe, reality, and perception can be linked to an overall healthy outlook and peaceful life. The ultimate takeaway is that everything truly is connected, and that has to include us.